I think we have video. Hi everyone. Long time no see. How have you all been? I think this camera pointing towards me. I'm not sure. I haven't calibrated this thing yet, so it's all sorts of weird. But college update going to UIUC. Wow, that's a great school. That's amazing. Congratulations, Huskabite. You've really made it. Ooh, ads. Yeah. We'll have a small party here today in your honor. Okay, so I also have Bellum and TMKDK, and apparently TMKDK has won the award for being first today, so congrats on that. Yeah. I am not building a crane, TMKDK, although it would be very scary if I was. Alright, so if you guys were here when I first made this thing, this is the Hyperloop pod that I made for my freshman year project, and it somehow made its way into my senior design project. So I don't know what's going on anymore with this thing, but I have to make some grave improvements to this. Oh, we put a robotic arm on it. So this is the Open Manipulator X from Robotic, and I zip tied a camera on top of it so I can get video feed to my Raspberry Pi, and it's non-functional, so I'm going to spend the majority of this stream just uploading code and getting everything to work together. But that being said, this is a pretty cool pod. It moves pretty fast, it's a little violent, and all of the electronics are incredibly stupid. So the driver, the motor driver for this pod, used to be an MDD-10A from Cytron, but I unfortunately blew up both of the drivers because these motors draw a crap ton of current when they're under load. So instead, what I got was this 80 amp ESC for brushed motors from this company called Hobby something. They're all like Hobby something ESCs. So anyways, so I'm gonna be attaching this to that today, and then writing some code for my controller that will just drive the pod back and forth. And then if there's time, I'll go ahead and just upload more code to control the robotic arm. But that's gonna be for later. So, oh hey Postron, hi, how's it going? It's good to see you all. There was a Hyperloop in the latest episode of Mandalorian. That's awesome. I don't watch Mandalorian, but that's pretty cool. One of my electronics projects is a model RC crane. Ooh, that's fancy. So, I need to remove this pod from the track just so I can like start messing with it and all. Oh, let me give you guys a room update. So I got this camera, for those of you who don't know yet, that's basically a 4K resolution camera. So it's supposed to be like really nice for streaming and whatnot. I can only stream in 1080p, but for Zoom calls, it's actually really awesome because I stream in 4K on there. So this is what the room looks like right now. Hi there. And I removed that central table that was over here and I put it outside because I needed room to do the projects on. So that's the explanation for that. The printers are still here. I haven't changed them much. Let's see. And something like that. 4K Beaver Award. Ooh, that looks like a room for exercise. It does look like a room for exercise. There is room for exercise. Maybe once I do have some exercises that I need to like get off the queue, so maybe I'll do those after I remove the pod from the track. So I'll be taking this to my workbench, and then we'll go ahead and attach the ESC there. And I also have some plans today to complete some PCB designs for Ad Sandwich, or PCB testing for Ad Sandwich, so we'll go do that too. But yeah, it's good to see you guys again, as always, and let's do some things. Oh, I also have my drone back there I'm gonna take a look at sometime later. Alright, first order of business, taking this pod away from the track, which is actually pretty hard to do since this pod is really heavy. But the way to do it is to pretty much have it on one end, like so, Is it safe? Absolutely not. But it does work. And let me just grab my electric screwdriver. And my bits. The only way to remove this pod from the track is by unscrewing these 8 screws on the front and the back of the track. We designed this thing. It's almost as tall as me. Like this pod stuff is pretty large. The pod can be an elevator. It absolutely cannot be an elevator. Like the pod can barely lift that weight by itself. Like you would need some stupid strong servos for it to do that. And unfortunately, I do not have that right now. That's not a luxury I can afford. I don't believe in the possibility of the exercise stream anymore. Scams. There is an exercise stream. It's coming. I just don't have the time to do it yet. I'm telling you, like, this semester is really crazy for me. So, I did promise V-grade exercise stream, but it's probably not going to be until maybe during the summer or whenever I get more time. But, so, we got one. Loose. So for these, I need to probably need to use some heat inserts or heat these in. I'm going to be unscrewing them and screwing them all the time. So otherwise, it's going to be kind of difficult, kind of inconvenient for this to happen. Alright, 1, 2 here. In fact, I think I just can remove these 4 screws. Coming up in April for me, April is, well, this month is probably the craziest month of my college career. Or, well, it's gonna be. I have so many events. And I already knew about this, that this April was gonna be that hard, but something I have to deal with before I can get out of here, I guess. Okay, got the top off. I'm gonna yank the pot now carefully. Okay, come on here. Alright. Pod's off. Man, it's heavy. Track's down. And let me bring it over to the workbench. I don't know if these fork wheels can handle the weight of all this stuff on top, but we're gonna have to deal with that. So I think I also have to work on improving the ultrasonic sensor placement on the 2 edges. But it is all 3D printed, yes. This is entirely 3D printed track. 8 segments of the finest PLA you will find on this earth. Hatchbox Black PLA, not sponsored. So each piece took my printer about 24 hours to print. 28 hours or something like that. So it adds up, but this is what it's traveling on. And this is for the purpose of battery swapping. So just to get that out there. Alright, let me go ahead and repair my exercise debt here. I owe some people things. I remember when I was streaming at like ridiculous hours, at like 3 a.m. Betty came into the stream and redeemed 1 push-up. And I haven't done that yet, so I have to do that. I have to do apparently 3 sit-ups for Vellum. Just scroll up on the chat. 3 setups for Bellum, and then whatever's in the exercise queue. But for what? Not Tesla cars. For drones! So, drones, in fact, I have to give a speech on this, like next Tuesday. So, we're solving the problem of drones having limited flight endurance in our project. This camera's tilted. So, drones, or in retrospect, unmanned aerial vehicles, because for the most part, these drones aren't going to be controlled by humans, but rather by code. And so they don't have a long flight time. These batteries run out from about 15-20 minutes after flying. So if you wanted to fly this drone for like 3-4 hours and on a non-stop flight at no end, you would have to like swap its battery eventually. So the procedure for all this is having the drone land on the ground station, have its battery swapped out, and then have it take off again, right? That's the whole idea, at least. And so I've developed this ground station in which I have this pod here, which is the battery transfer mechanism, and it's kind of the method of grabbing the battery and swapping it out. So not Tesla cars, but, well, if Tesla cars ever got a feature in which it flies, then yes, it would be Tesla cars, but we're doing this for drones. Imagine if you use 3 pieces of wood instead. Well, contrast to wood, which scares me, you know, like cutting wood terrifies the heck out of me, I'm okay with 3D printing. And plus, it's more of a flex to say that you use 6 kilograms of PLA to build something rather than having, you know, 3 pieces of wood instead. So like a Roomba. It's like a Roomba if it only goes in like 2 directions, in which this does. So this is a robotic arm, a 5 degree of freedom robotic arm given to us by Robotic Inc. And basically it has 5 motors, 1, 2, 3, 4, and then 5, and 6 if you count the one on the arm. And it has a camera on top of it. So this robotic arm sends a signal to the RS480. I don't remember which port this is called, but it's a port where it sends a serial signal up to each of the motors in the arm, and these are like smart motors, so they are able to communicate via that protocol, and all 5 motors can be combined with just 1 signal. You can turn the arm into your cameraman. That is true. That is true. I could write an algorithm in which it tracks the position of my hand or my face or whatever, and the robotic arm just like turns towards it. So if it wasn't meant for grabbing things, at least it could be, you know, used for some other cool things. But that's not what we're here for. We're here to fix the stupid power issues that come with this whole setup. I'm going to remove the ultrasonic sensors right now because, or at least the wires for them. I'll plug that back in later, but or I'm going to make custom cables for this actually. But this has to be like more neat overall, and I can't have just like random things going on about it. How many seconds does it take to swap by hand? Well, we've calculated the turnaround time for the entire station, or the entire ground station. There's 4 stations in total, and it takes approximately 2 minutes for the automated swap session. So that's calculated by having the drone land on the ground station, having the induction coil prime the hot swap feature, having the robotic arm grab it, having it transfer along the rail, and having it swap out on the BVM, the rotational battery chamber, the storage chamber that I designed on stream. Honestly, a lot of this project I did design on stream, which is entertaining to say at least. How long would a human take? Like seconds. But this is assuming that you have no human, you know, going in and swapping the battery out of a drone. And we designed a chamber, actually on stream, in which it could allow for this quick swap to happen. Like for me, it takes, with the zip tied on the battery, it takes me like approximately, let's say, 30 seconds max, right? But for a robotic arm to do it, it's gonna take longer. Alright, so I have ultrasonic sensor here. I'm gonna pop the other one on the other side later. But aside from the bright neon yellow like landing pad, which I think a darker color would have worked, or so you have to be a few seconds by this device. Well, the benefit of this device is that no human needs to be there to actually swap the battery on the drone. So if you're having a lot of drones in the air operating on some task, then this robotic arm would be able to like automate that. Like you wouldn't need a human to be able to sit there and swap out batteries on drones. Sort of like how you wouldn't need humans to, well, I can't think of an analogy right now for that. So a lot of times these UAVs come with a flight computer connected to the internet. So it's automated flights. So these drones come with a Raspberry Pi or some other means of connecting to the internet in which someone from somewhere can just send a command to the drone and get it to fly. And it does an automated mission. So they just send it the coordinates of where the drone wants to go, and then the drone just flies there automatically. Like there's no human actually controlling the drone. It is illegal right now, but UAVs are being used in the military, and it's being used for those applications. If they're not FAA regulated, of course, you know, it is illegal to just fly to somewhere, but it's what they're working on right now, at least for these defense companies that I'm doing these projects for, and that's what they're asking. Yeah, so only the police and military can do it, not just like regular people. But, you know, this project is technically for the military. Don't quote me on that. So we are able to go on the idea of having that complete. But if you're doing the UAV flight on like a regulated farmland, then it is okay. I do know of the legalese that comes with flying automated vehicles. Okay. So, I need to strap this ESC on, in which I might have to like unclip this wire in order to access the wires that are actually being used for it. I don't think even the police can do it right now because like UAVs are such new technology, or it's such a new technology that it hasn't been fully explored, and there aren't enough laws to specify what you can or can't do. In terms of UAVs just yet. And no one really has experimented with full-scale development of this technology, so. Alright, let's see what we're working with here. So we have, well, I have to like manage these wires while they're strapped onto the vehicle, which is gonna be fun because I have to like heat shrink all this crap, so I have to be really careful. So I have this wire, which this wire is going to be connected to the main plug. So the other side needs to be onto an XT60. This one also needs to be onto an XT60. And so these just connect together, that's main power. And then these ones connect to the motors, the yellow and the blue plugs. And so the motor will be this pair and then this pair, so these four. And I need to put these little pink connectors on it because these are male connectors. I think they're for like 20 to 22 gauge, and they just plug in neatly like this. So the police can catch the criminal and you have to dox yourself many times. That is true. I mean, from the times we explored the automated flight in this channel, I already have doxed myself many times. So a lot of drone, actually the latest workshop I did for the workshop series was actually on flight control. I still have yet to upload the video, but I did talk about surveillance applications. Actually, I think there was like this one YouTube channel that built an automated drone for surveillance purposes to catch criminals on their own private property. And that was pretty cool. Don't remember the name of the YouTube channel though. Really search it up. I don't know. Okay, so we have to do a little bit of heat stuff, which is great. So crimping and then heat going. Luckily, these already fit really nicely into this port, so I don't think that should be much of an issue. What's more of an issue is, just let me get my crimper right now. Just be careful that FBI does not jump your door. Yeah, we have a lot of safeties in place just to make sure that everything we're doing is totally legal, and we have trained professionals to fly our drones. The big ones, at least. I can fly my own drone. It's under like the trust certificate that I take. I I've actually gotten pretty good at flying the drone lately, surprisingly. So you have to take this like little test before you can actually be allowed to fly the drone out to the out, not in the public, but in like safe areas. And you have to just be mindful as all the pretty good at flying. Hey, you guys were here when I first learned how to fly a drone, and I did it indoors, and that was an extremely bad idea. We still have the ceiling eater drone, the original one that I built. You did a pretty good landing last time. Yeah, I'm slowly getting there. I mean, the first time I flew the actual drone was about a week ago, and I've just been taking it from there. So let's just grab this. I do know how to crimp, I promise. Okay, that should be good. That's not good. Oh boy. Okay, let's try again. But you know all the stuff from the military has to be quality soldered. Yeah, I realized, Team KDK. I realized that this janky method of prototyping is not gonna fly inside the military, but you know. We can all dream. Okay, now I have to apply some heat to this. I have to apply heat without like burning everything else, which mission accepted. Like my heat gun thing is over here. All right. Time to attempt this heat gun test without burning everything on my desk. Heat gun. Okay. Don't burn myself here. Okay, one side is heat gun, now I have to flip it over and do the other side. Okay, that's pretty good. Alright, I am going to do a continuity test later to make sure that it's actually continuous and safely continuous. But for now, I think this connection's pretty good. Okay, now to the next one. We have all seen board explosions, hopefully not today. I remember testing with the other motor driver. The other motor driver had a 10 amp limit, and I thought, oh, it's 10 amps, that should be enough. Spoiler alert, it was not enough. The entire board blew up, and it caused a small fire. I literally saw a small flame sitting on top of this MOSFET that was on this PCB, and I was like, oh, that's not good. I should probably stop it, you know, stop the fire. And it looked like you could cook a marshmallow on it. I mean, if you were in the wilderness and you were by yourself and had this pod, you could start a fire by just plugging it in. Is that the one in the video you posted? No, it was a different one. Because the one in the vid I posted was already broken by stress testing the pod. And what I did was I tried to replace the broken chip with another chip from another broken PCB, like doing a chip transplant. And what happened was, the moment I replaced that chip, another chip blew up, like even harder. And it didn't smoke or anything, it just went kabloom. So I experienced my first extreme board explosion that day, and I wish I could have recorded it, but it was pretty violent, to say the least. Okay, this one's good-ish. That was why you had the LiPo battery lecture. Well, no, the reason I had the LiPo battery lecture during the event was because I came across too many projects that I am currently mentoring that consist of people not knowing how LiPo batteries work. And they are just destroying them and like harming them and permanently disfiguring the LiPo batteries. And it saddens me, you know? Even in my own project, but I'm not gonna rat them out. But you know, the more people know about the dangers of LiPo batteries and how to safely take care of them, the better. Multiple fires, yes. Like, I wouldn't call myself the most careful person in the world, right? But at least I try to do so. At least I try. Okay. So these two wires are plugged in. Are they continuous? I have no idea. I have to check later. But so two are good. The other two, actually, I can check now. Multimeter. This pod, this vehicle, is an abomination to mankind. It's fast. It's hot. It's explosive, and I am genuinely scared of it. At times. Okay. It is continuous there. It's not continuous there, which is not a good thing. Just kidding, it is. Okay. Good. This connection will power the pod. Good. The next one is going to be a little harder because it's like more inside of it. It's not like sticking out or anything. Maybe I could do it from this side. Rotatey potatey. Oh. Oh. Uh-oh. Uh-oh. Okay. Just going to rotate the pod to this side. Well, I'm gonna exercise my carefulness here and rotate the pod to this side where I can access the wires better. Like right here. You can't see it. It's probably for the best. But, I don't know what the best way to do this is. Probably just, like, down here again. This pod is heavy. This is one of the most, well, all throughout college, I've basically just been recycling projects, right? And upgrading them in order to use them for other things. Like, we built this Hyperloop pod on stream a long time ago, and I'm still using it for who knows what. Actually, it wasn't that long ago. Probably like a year ago. I built a drone about a year ago. We're still using it. Oh, what happened? I did the battery vending machine on stream. Okay, I think that goes in. Okay. It's all going to use. And basically, the entirety of this month is just going to consist of me presenting this to a lot of people and hoping that they like it because A, it's part of my grade, B, it determines if I'm going to graduate, C, if they do like it, they might give us more money. And money is good because you need money to do projects, and if you don't have money, you don't have a project. Come on. Heat up, you stupid connection. that's the story of my life for the past month. And this is my last semester, so pretty much I am vexed daily, trying to figure out how I should balance literally everything I do, because not only do I have to complete all the projects, I also have to start finding people to replace me for the projects. It's like if someone quits at work, you have to find a replacement for them. Except in this case, it's very, very hard to find a replacement. Because, unlike work, the turnover time at this school is like a year. Money is always good, it'd be great, you know? I like money, it's hard to get money, at least engineers get paid well. Because if I went into a profession that's as intensive or money intensive as something like this, I would also want to get paid. We will all replace you. That is good, Bella. You can come back to college. Be my replacement. I don't want to do this anymore. Okay, I need to get one more of those connectors, because I busted this one. It's a cry for help. Of my slow deterioration into madness. All right. Stuff it inside. It's a cool dilemma. Okay. Oh, where'd it go? Okay. This wire here needs to be heat shrinked. Wait, which wire needs to be heat shrinked? This one. Come back. So I have heat shrinked everything, at least all the connectors. So these connectors can now go onto the vehicle. I might have heat shrinked everything else in the process, but hopefully it doesn't, you know, spontaneously combust. I do have to continuity test that connection though, so I will make sure I do that before I plug everything else in. Oh, come on. If a criminal sees this battery station, the first thing they'll do to it is destroy it. Well, so do we need like self-defense systems for these battery stations now? Do we need to put like a laser turret to it just to make sure that criminals don't, you know, walk by it and destroy it? Laser turret? Alright, I'll add that to the list. So when I present this project on Tuesday, the first thing I'll say is, you know, if criminals were to steal it, we would just build a laser turret in order to protect the turret from destruction. Yeah, special for all that near it. Sure, sure. I'll credit you for that idea, Team KDK. Make it so that it scans the person that they're not authorized, then the machine throws a bomb at them. I think that's a little violence. That's like using Chinese facial recognition. Kind of, yeah. Alright. So now I made these connectors in which let me just test fit them to make sure they fit, which they should. Yeah, they fit great. I love these connections. Okay. Now the pod can go on the ground. I need to go ahead and solder some XT60s connectors, and then we can go ahead and put it on the pod. Do you guys smell something burning? Huh. Smells like fried chicken. You need drastic ideas for problems sometimes. See, now you see that's what makes you a great engineer. Alright. So I am literally manually switching to my, what I call my tripod camera mount mode, in which I mount it to my pegboard, rotate the camera. There we go. So now you all can see my beautiful workspace and where I like blowing stuff up. No, we don't smell anything. Okay, good to hear. Good to hear that I am not going crazy. Alright. See? Now you get the full unfiltered view of everything going on. Alright. So I need to solder some XT60s connectors together. Which this is going to be the one connected to the battery, and so I just need to connect, let's say, a male to this and a female to this, just to make sure it's like male, female, and it's all like connected, because it's going to pass a lot of current through, and I don't want it to go boom boom. Boom boom is bad. Typically, boom boom is very bad. Alright, now time for some soldering. We love soldering. Alright, Just gonna plug this part in first, so that I can put it in later. Then let me just find the markers on here to tell me which one's what. This is black, and we can start soldering this together. Gotcha Baited did see the recommended list one was called Nerduino, but they did not play with Arduino for technology and science. They have a channel that's very closely named to Arduino, but they do not do Arduino. Well, I mean, if that isn't something. Come on. So what I do for these is I usually place a glob of solder into the channel here. I create a pool of solder in there. Put some solder on the wire to prime it. That. And then I connect the two together. Oh, come on. I got this nice little tip that has a hooked end so that I could like heat stuff up in like weird angles. It's not heating up. It's not heating up enough apparently. Ah. I think this was meant for like more of a precision tip. I have to change tips to something less precise. Maybe like this blunt one right here would do it. Former professional astronomer and NASA scientist chatting about the latest breakthroughs in space, science, engineering, technology. When we're not sciencing, we're making cool builds, playing KSP, tending to bees, and chilling out. They are a beekeeper, eh? I need to change the tip to like something that's not going to be detrimental to my health when I'm soldering these XT60s connectors. And basically I'm going to use a cheap like 20-cent solder tip. Like, this thing's going to disintegrate within like 3 uses, but you know. It is what it is. Look at this fancy tip. Here. Like rest here until I use it again. Go on here. Go on here. And you go on. Should be slightly better for soldering stuff onto XT60s. It's got a wider tip. They are also ending. Ah. See. Alright. Let's turn this back upwards. Just gotta get this soldered. They were looking on some Raspberry Pis at the end. Ooh, are Raspberry Pis back on the market yet? So I need some more solder. Or do I still have to buy them at scalper prices? I looked in RPi Finder the other day, saw nothing though, which was tragic. I finally got it. Gosh dang it, that was much more difficult than I needed it to be. They raid cost table, I follow them before they end. I don't know who that streamer is, sounds interesting. This one needs more solder. Okay. Well, this one's done. Ish. Done-ish. Just gonna put this cap on. Okay. So this cable's done. It's a neat little extension cable. Oh, you guys can't see it. There you go. If they have not seen a Raspberry Pi project in the last few seconds, I would not follow them. I see. Well, it's close enough to an Arduino, you know? It's close enough to an Arduino. It's close enough. Alright, let's go ahead and attach the XT60 to the ESC. So I'm gonna put this on. crimping? No crimping. We're not doing crimping. Not on this channel. There will be no crimping on the Lok Lok Fafa channel. Ignore the crimping I just did earlier. That does not exist. Schrodinger's crimper. You know, I have to like watch out with my soldering iron and not like hit the camera. Like, that's my greatest fear right now. And in all streaming, like I'm not careful enough. I hit the camera, then the camera goes bye-bye. That would be a totally tragic incident. Align, please. Please align. It's not like aligning straight. It's like going in at a slanted angle. I think I need to like clamp it down or something. Okay, let's try again. Hi Kendarsa, how's it going? How was your day? Do you have anything interesting for dinner? You know what? That's good enough for me. Alright, just make sure that I did it right. Black plus minus. Looks fine. I'm gonna say it's fine. I don't know if it's fine, but let's say it's fine. Alright. Yorkshire pudding. Fancy. Whoa! You forgot about the shrink tube. Well, you don't need shrink tube if it's like one of these connected, right? It's like separated on the inside. Sorry about that. Okay, I need to go grab my double-sided tape and my batteries so we can test this using a PWM tester. I don't have that boot. I usually have I have a bunch of boots. Well, it comes with the XT60s. I think they're nice. It's better than heat shrink in my opinion because it's like plastic around it and there's a divider on the inside, and plus it's like really hard to like punch through, where like heat shrinks usually, you know, are kind of holy. Oh, you're right. Back with my battery pack, back with my double-sided tape. Life is good. Still something blows up. Sounds like a nice I should look into one. I've been soldering a little too much lately. It's giving me the sniffles. Alright, so I connect this to a battery or connect this to a pod, and then we test it using the PMW tester. Yada yada yada. Pod doesn't blow up, pod actually moves, we win. That's the game plan. Just do a slight amount of cleaning first before I go into that testing. This goes here, this goes here, this goes here. That goes here. Alright, station's cleaned up. Let's go ahead and test it. Alright, pod's coming back. This tripod needs to come down because pod's gonna take up the entire desk. Get a nice view of the Raspberry Pi. Go back to watching a movie. All right, enjoy your movie, Kandarsa. I will see you next time. And I have to flip my screen 180 degrees again. At me if you want. Okie dokie, will do. Did I ever do that exercise I said I was gonna do? I didn't, huh? All right. Well, after I test this, I will do the exercise. We'll have a short exercise stream. How about that? Is V great here? Alright, so I have this nice little PWM tester for servos, and this nice little servo testing cable. There we go. That I've used to test drones before, but I'm gonna use it to test different things now, including the ESC. See that. How's that for a view? Good enough. You guys can deal with the slight glare, right? Okay, now it's hitting behind the robotic line. There we go. Much better. I found the correct angle. All right, so. It's zip tie heaven. There's my zip ties. Zip tie in time. My bag of zip ties is slowly running out, unfortunately. This used to be full of zip ties, and now it's like about an eighth full of zip ties. So I go ahead and cut these zip ties off. These are not black zip ties. They are imposters. They should not exist. Down. And I will re-zip tie them with black zip ties. Eventually I'm gonna have to take this yellow plate off, and I will have to re-zip tie everything to it. The yellow really doesn't look that great, but right now it's bearable. I'm not gonna waste time replacing it as of right now. Okay. All right. So how is this going to work? Well, this is going to plug into the ESC tester. I'm going to plug the battery in to... Okay, hold on. So battery goes into this port, and then the motors will be going into this port. And so I'm not going to plug in the motors until I figure out what's going on with the ESC, in which this is the on-off switch. So it's currently an off, which means I can plug it into the battery. This would be right here. Just make sure the connection is right. Yeah. Black goes to black, red goes to red. So ESC goes in, and then turning on the ESC now. Okay, we have ESC power, and now connecting it to a servo tester so I can see what the output's like. Oh, it already has servo output. Okay, so we have servo signal here. That blinking light probably means that the servo is receiving signal. Now this servo tester goes from 800, I don't know if you can see that, 800 to 2200, and there's different modes. So you can select this mode, which just goes to the center, which is 1500. This one rotates from the two directions, and then I think this one is just, this one's just manual. So I'm gonna set it to 1500 because it's the center, and then I will manually test it from location to location after I plug it in. These motors are terrifying. They are very, very violent. So for these connections, I will go ahead and connect the back motors to 2 of them. I don't think the order matters. I will just change the order, you know, once I understand which direction the motors are going in. Plug it in, and then plug it in. These are probably going to heat shrink together because, you know, heat does things. And there's a lot of heat in this. And then for this connection, for the right motors, it's going to be black on the right, red on the left. Okay. It's connecting really well, which is surprising considering the amount of questionable things I usually do to my electronics. Okay. So this is set to 1500 on the servo tester. I am going to test the wheels to see which way they spin, and then I'm going to connect the battery. I'm going to put the servo tester on the screen for you to see. There's probably going to be a noise. Okay, there's no noise. It's on. There's no light. Okay, I'm going to slowly turn it to the right now. I'm kind of scared to see what happens. There's a blinking light, which I don't know if that means there's a signal or not. Usually for these servo testers, the signal is on top. Okay, I'm gonna increase it slowly to see what happens. I'm actually kind of scared. Do we see smoke? I sure hope not. I mean, this thing is a chonky ESC. I'm gonna be surprised if it does smoke. Okay, nothing's happening so far. This is on. There is battery power going to it. I am kind of nervous. It's not powering on. Get a little turn on there too. I'm scared to turn up even higher than this, because like I'm getting no signal. Let me read the manual for this because I'm not sure like what the light means. If it's blinking red, what does it mean? All right, let me take a look at the Amazon link in which I bought this from. Because I know the power of these motors. I know what they can do, and they are genuinely terrifying when they're in the hands of the wrong people. So let me just double check that I have everything set before I, you know, do a thing. I'm doing a motor test right now, Pyromike. So let's see. So the motor should spin. That's what I'm trying to get. But right now the motors aren't spinning, and I'm a little nervous. I mean, I've already had 2 motor driver explosions for dual brushed motors. All right, let's see. Blah, blah, blah. Very easy to install. Probably want 1860 program card, change settings, use different vehicles. Do you have to program this? Default set for life of batteries. Okay. That is true. Okay. Looks like it just works like a regular ESC. So if I plug it in and rotate the servo, it should move. But I'm scared to rotate the servo. Okay, going back in. That's the wrong connection. This is the right connection. Okay. Well, here goes nothing. Nerve-wracking time. It's 1800. 1900. Should be moving now. Okay, it's not moving. And that makes me like more nervous than ever. The motor should be moving. 80 amp SP SVC. Motors are not moving. I wonder if they're blown out. Let's see. How can I easily test these motors? Okay, I'm gonna use my power source and just like connect them to it, just to see if the motors are working themselves, just to make sure it's not the ESC, because now we're running into issues in which the ESC is not working, so, or not working as expected. So these motors usually run at 9 volts. So if I take my power supply and I run like a 9 volt signal through it, and take your demon and see if it gets some current and voltage. That's true. Okay, let me do that next. Let me go ahead and test the motors first. So I'm going to go ahead and just connect red to black to my power supply and see if the motors spin. Because I did blow out the motors. So here we go. Okay, the motors do spin. They are very violently spinning. Those two motors are fine. Let me see how much current it draws. About 10 amps. It draws about 10 amps of current. These motors are very, very, very violent. Okay, let's see how much the left one draws. Or if the left ones work. Yep, the left ones do work. It's also drawing about 10 amps. Okay, so it's not the motors. 10 amp continuous, yeah. Yeah. Well, let me run it for some time, and I'll let you know. Let me just point the camera to where you can see the... Oh, where'd it go? See the power supply here. So the start is 10 times higher. Yeah. $100 amp start current. Maybe that's why it popped. Maybe that's why it popped. So the motors work, and maybe that's why it was like handling such high freaking current, because of the whole 10 amp thing. But okay, so why is this not working? Let's see if it's being powered at all. So I need to get my multimeter and plug it in and see if anything happens when I turn up the stuff. All right, so plug this in, and I'm gonna go ahead and put this on. On? No, on. Okay, it is on, and I'm gonna put it on the mode where it goes from like low to high. So it's going to go between the two high and low points. You You can make soft start so you lower the current. I started at 1500, so it should not go higher than that. Even if it does, the peak current for one of these things is about... okay. I'm wondering if there is a start protocol for these. It's saying 0 right now for voltage, which might explain why. So 0 for that, presumably 0 for this as well. I have to find the user manual for this and see why it's not working. So it's the ESC. Hold my non-carbonated drink. It's not a dead battery, TMKDK. It's just that I think the ESC is on some safety mode that prevents me from actually using it. Because comparatively to other ESCs I've used, that's how it generally works. The battery's not dead. The battery's at... well, let me check the battery now that you say it. The battery's at 12 volts, so it's not the battery. I'm okay, look, the battery's not dead. I can power like literally the rest of my electronics with it. Like it powers the entire pod and the U2D2. So battery's not dead, it's not the battery. I think it's just the safety mode on the ESC. So the ESC is a QUIC QUI quick run. It's a quick run 80 amp ESC. I just have to find the user manual for it and figure out exactly what the heck's going on with it. Quick. Because I had the manual, but I threw it away, I think. Okay, here we go. Hobbywing. You unboxing Hobbywing Quick Run Q880 dual brushed ESC. Let's check this out, I guess.
Hello and welcome to these bullet connectors. You can see that these. It also comes with.
Oh, you're supposed to put a fan on this.
It is with the fan like that. The fan cable is a little bit long, so that's also programmable.
Okay, this guy doesn't actually use it, so I don't know what's going on.
Need to
where's the guide for this? Manual. User manual. Because I would connect this to my Arduino, but I am very scared for that as well. This should go like over here or something. Okay, so it tells me to mount the safety switch on the side, which is smart, for sure. And then there's a fan that's at school right now, which I have to get later on. I guess that just completes it. Okay, I think, oh, here we go. Hobbywing, quick run.
Crawlers these days, workings for this sensitive. You're very concerned, real responsive. This is going to be basic connection and I guess setup, if you will. There's really no setup is the beauty of it. So I have my two motors. You're trapped to this chart. The black wire of the 3-wire harness is going to be an easy one. So you cycle through with items and you select them with values. So I change the value, and then now we correlate with the battery pack. Lights come on, and then you get some numbers, and those numbers, the item and the value, are going to correlate with the program. You get speed control on, it's connected to a battery pack. Lights come on, and then when you turn the speed control
on, that's kind of stupid.
It's connected to a battery pack. Lights come on, and then you get some numbers, and those numbers, the item and the value, are going to correlate with the programmable item. Copy that. So you prompt and this guy.
Okay, what I'm going to do is I'm going to assume that the servo controller doesn't work for some reason, and I'm going to make a small program on my reprogrammable controller here that can send a signal to the ESC from an Arduino. That way, I will see what happens to it. Put your scope probe on the motor for current and measure the current. On the motor or on the ESC? Because I'm pretty sure the ESC isn't compatible with that servo tester, but I can upload some code onto the ArduPod and see if that works. Because I think that might be a better test. Let me go and do that real quick. So this would be the same code as one of the previous scripts I've written, which is good. It's already there for me, available to use, so it's just the hello car script, I think. Let me just connect that. Speed. Alright. Programming cable. Oh, all my ports are being used. Okay, I'm gonna have to delete one of the ports in order to actually program this successfully. I guess my headphones are going away. So, I'll be able to hear you guys, but... Oh. You guys got like feedback audio from like my computer. It's just temporary until I can get... Actually, I just shot the music. It's temporary until I can get this thing programmed, because all of my programming ports are apparently used. Alright. So this goes here. I have to program, I think Telocard is. Yeah. So I did a bunch of projects in which I programmed different card codes. And one of them was specifically for like ESCs, which this was made for. So I'm gonna reprogram the card to do that. I'll plug in the motor connections right now just to see what, just to give it some oomph from the start. Motor connections here, motor connections here. By default, apparently the video I watched said it's by default for LiPo batteries, so I'm gonna trust it on that. And that if I need to use like nickel metal hydride, it'll be for a different one, but who knows? Okay, so it's connected. I'm gonna put one zip tie on it just to hold it in place. And I gotta go grab that fan and screw it in when I get back to school on Monday. Okay. ESC zip tied on, nice and snug. I might actually not even need the... Yeah, I don't even need the extension cord for this. Just directly connect it to it. That's nice. Okay, so I'm gonna plug this in. The 14.8 volts. All right, that's gonna work right there. Okay, so now let me just go ahead and reprogram both of the microcontrollers with the code and then test it with the Arduino to see if that would do anything differently. Alright. If it doesn't work with the servo tester, when are you going to pick up the box of resistors on reels I don't want? I don't know. Whenever Ad Sandwich can take us down there and say hi to you. ArduPod TC. Telecard controller. So the controller's first. Canarza, you missed me plugging the servo tester or the PWM tester into the ESC and it not working. So I'm thinking there may be some sort of like safety feature that I have to unlock before it recognizes the signal coming from the car or the controller. I measured the voltage on the outputs and they say 0. I think the tester would cover that, but I'm just going to use my code just to be safe because I know the code works on like multiple vehicles and I know the tester doesn't always work on them. And the motors do turn fine. None of them are burnt out, thankfully. So sniffing out the errors one by one. Here. No, this one's a special ESC. These motors draw a lot of current, like a crap ton of current, like almost 100 amps of current at peak. Okay, just uploading the sketch for this controller here. That has the tello card. Okay. So tello card is turned on. Safety's not on. It's on manual. And the switch is going to turn bound, right? Bound. Okay. And then I have to program the one on top of the car now, which would be this one. This one should be programmed with the script RDPOT-TC. Does your ESC have a switch? It does. It's on. I know it's on, Cadarsa. Because the light turns on, but the light is flashing. And usually a flashing light on an ESC means that it's not reading the signal properly from the transmitter. This one, it should be a 2 to 4S LiPo ESC, and it has 2 ports for motors. So it's usually for like Traxxas RC cars. I have no experience with ESCs. Well, this one has a switch. It's fun. Okay, so it's connected. If I turn it on, it should be connected with speed. Okay. And speed's 93, and I can change the bound to like 97 or 86. Great. So I have my servo tester ESC that works with Arduino. I'm just going to plug that in. And then if I plug in everything... Okay, let's see here. So the Arduino should work fine. Get this out of the way. Alright. So plugging everything in, just make sure all the connections are fine. Yeah. Alright, I'm going to turn the ESC on. ESC's already on. And it's not getting a signal from the... It's not getting a signal from the Arduino. Well, the light's off, which I don't know if it's a good thing or not. There's a blinking light on the ESC, which tells me absolutely nothing. Is that under voltage? Okay. So whenever I try to turn the signal to like a drive mode, it blinks, which means that I have to figure out what the blinking light means. I'll be waiting. Quick run 880 ESC blinking red lights. Red blinking light of death and how to fix it. Great, I need this video. Yeah.
You call up Horizon Hobby, they actually give you the wrong. You've got the radio on as you can stop in. Okay, you got no power. Turn the steering wheel though. You got steering.
Well, I don't have steering, so that's not gonna be a problem for me.
The ESC, you obviously have signal to the servo. You're able to turn the wheels, but the car does not. Actually, not bad. So I'm going to cover how do you. The car is going to get both throttle and steering sent to it by the radio. And when it gets the steering, it's going to turn the servo to where the steering is according to where you have the steering wheel turn. The other thing it's going to do is send power to the throttle depending on what it thinks you're doing with the trigger. Now there is this little tricky knob right here that says TH right there in the middle. It stands for throttle, and you're probably wondering what is that knob? Well, it is the throttle trim. And what that little knob does is send a signal to the car when your trigger is at neutral. So when you let go of the trigger, what signal is it going to send? And if you also notice, there's a little dot. So if you turn that wheel, that little arrow up to the dot, it's going to send 0. So when you let the trigger at 0 and you turn on the car, it's going to send 0 signal. Now, on some cars, like a nitro car, maybe 0 isn't quite right. You want a little idle or something, you might turn it up a little bit, or maybe it's off a little bit, you want to turn it down.
So there is a
What you want is to
safety
always
lock.
have that thing at that little dot. That means 0. When you let go of the trigger, it's going to send 0 to the car. Now, when you turn on the car, it expects 0 for the throttle, and the reason for that is it does not want to just launch this car straight into the wall in case you accidentally have the trigger.
So I do have that programmed in. It's the offset. So I have a knob here that programs in the offsets, and I just have to find the right offset, I guess. According to this guide.
Pull the trigger, turn on the car. Well, it's just going to launch on the car down a little bit. It thinks you're trying to send it either a little positive throttle or a little negative, like reverse, and it won't let you turn on the car. So watch. You set that little arrow up to.
This guy is. I'm gonna do a play-by-play as to what this guy is showing. So he has an official controller, like the radio controller that you can buy from commercially. But if you want to hack it, you have to find basically the correct ppm value in which it zeroes out the ESC. And if you don't do that before you actually start modifying it, basically, if you turn it on and it doesn't see that 0, it's going to complain at you. So in order for us to actually operate this ESC, we have to find exactly what PWM value that is being sent, or which, from 0 to 180 degrees, what offset it has to send to the ESC in order for it to turn on. So this switch should be able to operate that. And so if the offset is 90, which was what the servo is at, and you turn on the ESC, it should not blink. Okay, which means, okay, so the ESC is not on, which means 90 should be the optimal point, I guess. No, that was wrong. So 90 is not right. So if it's not right, it'll blink at you, I think. Well, oh, that's new. So 91 maybe? So then, and now I got 4 flashes. I don't know what that means.
To the middle right there, neutral, turn on the car. You don't have that little blinking red LED of death. You got throttle. You got
yeah, okay. So I have to create some custom code for this.
The middle right there, neutral, turn on the car. You don't have that little blinking red LED of death.
Okay, so when we turn on the ESC, if we see blinking red light of death, it's not going to let us drive, so we have to basically find the correct... this one's kind of annoying then. Okay. So we have to find the right value in which we turn it on. So it's not that. 91? Not 91. 92? Not 92. 93? Not 93. 94? Not 94. 95? Not 95. 96? Not 96. So it's one of these values that's really annoying. Okay, let me pull this out. So if I plug it into the servo tester, basically I have to scroll through all of the values near the middle in order to figure out which one's the center. Okay. And then actually try to find that. I guess that's how the stupid ESC works. The device doesn't have a data sheet. It does, but I left it at school. So it's not here right now. And even if it has a data sheet, it's not going to tell you what correct value is supposed to, work. Let's find it. Quick run ESC. It's there as a protection measure because in case your throttle's a little too high or low on startup, it'll shoot the car out. But usually, if you put it back into the correct range, it should be able to. It should be able to run correctly, but Alright, come on. Well, I'm gonna like scroll through this ESC first, ESC tester, to see which stupid ESC value doesn't cause to have a blinking value of death at the very beginning. Yeah. Solid red light now. Yeah, blinking red light, blinking red light, blinking red light. I hate this. I hate the way that's programmed like this. It needs to have like a exact. Okay, so let me just position it to 1500 first, which is like the center, right? Okay, well, it's not the center. It's not that. Basically, if it doesn't receive the right signal on boot that tells it that the throttle is 0, it's going to yell and scream at you and kick at you. So we have to find the right value that will get that to happen, or that will make that happen, and that is hard because I have no idea I have no clue what it could be, and my controller is probably not precise enough in terms of like the resolution in which it would actually make this happen, or actually allow it to be the right. So I have all values between 90 and 96, and none of them, it seems, were the right values for this. Wait, well, it goes in two directions, so the center has to be some value of 90. Let me watch that video again.
We got throttle, we got reverse, we got steering. Car is good to go. It's fixed, voila. So that is what's
solve my
going on
problem.
in that red blinking LED of death. Check this out, make sure your throttle is at neutral, and then see if it actually runs. You actually have to turn off the car, turn it back on.
Blinking red light. Receiver did not bind to the transmitter. Well, I have a custom receiver, so that doesn't help me. I have to sweep through each of the value. Yeah. Some data sheet for this though. I have to do some a little bit of reverse engineering. I don't know, because like officially you need a transmitter that has the right value to plug into this, but I don't have the transmitter. So what I basically am trying to do is to sweep through the values to see which one actually turns this thing on, because all ESCs have this kind of protection measure in them, in which it doesn't allow you to do funny things. And so I'm just gonna sweep through it. I'm turn the bound to like 5 or something, and then increase the throttle and decrease the throttle until it turns the motors on. But like this ESC is different because apparently you can't, like, after you turn it on, if it doesn't detect it at like the first instance it turns on, it just doesn't anymore. So I don't know what to do. Not that. What is the freaking manufacturer's code for this? Because people don't like hack their controller. They don't like send a custom signal to it. They usually just, use something that makes sense. Mm. User manual. User manual for quick run series brush speed controllers. Okay, let's see. Short and peak current, peak current, peak current, peak current. Once the power is wrong connected, blah blah blah. Protection features for 4S LiPo, 3S LiPo. LED blinks to indicate low voltage. What if it's set for like a different voltage? What if I need the programmer card for the ESC? After turning on, the red LED blinks, but the motor doesn't work. Okay. Throttle wire is wrongly plugged into incorrect channel. The ESC can't successfully complete the throttle range self-calibration. Okay, that's what I need to find out, because this ESC doesn't work the same as the others I've used. Plug the throttle wire connecting in the right direction in the throttle channel, usually channel 2 of the receiver. Well, it's going into the receiver, so that's not a problem. And then set the trim of the throttle channel to 0 or turn the knob to the neutral position. That's the issue. I don't know what the neutral position is for this. Like, I don't know what it is. It should be 90, right? It should be like half. Unless it's like 0 or something weird. Unless it's I honestly don't know. But like I can try. I can try. I have to find out at which position is the stupid thing going to work. So let's try 0. It's not 0. Let's try the maximum. It's not the maximum. So it's some number in between, which doesn't help. Well, the datasheet isn't helpful. The datasheet just tells me what I already know. You know, what would be helpful? Full throttle forward, maximum brake, full throttle. Partial throttle forward, partial brake, or partial throttle reverse, and the LED blinks. The ESC. Calibrate the throttle range. How do I calibrate the throttle range? It says automatic throttle range calibration, easy to use. Yeah. On the ESC switch, set the throttle stick to the neutral point and wait 3 seconds for the completion of throttle range self-calibration. Beep sounds emits if the self-calibration is successfully passed and the ESC is ready to run. Okay, how do I do that? Begin to use the new brushed ESC. Turn off the ESC switch with the wire the battery, motor, servo, ESC, blah blah blah. We check the wiring to ensure all connections are correct before getting to the next step. Once the power is wrongly connected, that means the battery polarity is mistakenly reversed. Irreparable damage may occur to the ESC and batteries. Therefore, please pay close attention to the battery polarity because they couldn't be trusted enough to make their own reverse polarity protection. Turn on the transmitter and set the parameters of the throttle channel like DR, EPA, ATO to 100%. If there's no LCD display on the transmitter, please adjust the corresponding knob to its limit. Set the throttle trim to 0. Well, I don't know what that is. Calibrate the throttle range. Okay. Well, I tried doing that, but then it yelled at me and said I was wrong. So I'll set it to neutral again, or what my controller says is neutral, which is like about 90. Okay, this is like directly neutral. There's no more neutral you can get than like 90. Okay, so it's a 90, which means it's neutral for the controller. I flick it on, and it doesn't like me because apparently that's wrong. Because apparently this ESC just doesn't like working normally. What is the model number? This is the Quick Run 880, 880-dual. So I need to find out what the wait 3 seconds for the completion of thoroughly self-calibration. ESCs and their stupid calibration tactics. 80 ESC. Throttle range calibration, easy to use, that's what they say. Receiver, battery, yada yada yada. I feel like this just copy pasted the previous one I read. Neutral points. Arduino controlled ESC for brushed. Oh, wait. There's an Arduino library for this. Let me see if this is like any different from mine. Hobby Wing control ESC by Tungsten EXC. Yeah. Throttle min, throttle max, throttle big. New throttle, map throttle between throttle min, throttle max. Yeah. I might be looking at a different one. 1500 to 2000 throttle big. I have to see which value. Well, see, it says like it's not. It's fine right now. Do I have to increase it even further? Like, how much do I have to increase it by for it to work properly? No, it's nothing. Okay. So on boot, it has to already be the right value. Quick Run 880-dual. 880-dual. How do you set a jumper for non-programmable mode? I don't know if I need to do that. Because this is just a simple signal, right? Sensor read, throttle value, update ESC only by reading differ by 5. Well, let me find this guy's. I'm looking at a GitHub repository right now with like similar code to this, and check his YouTube channel, see if he has a similar video that I can like reference. This is all Nerf gun stuff, Tungsten EXC. But the repository looks like it is trying to find like the center neutral points, like the exact value for it. This is some shooting code for Nerf blasters. But the ESC, okay, the ESC doesn't. New throttle, sensor value. Well, that's the exact same thing as my tester then. Like, and my tester doesn't work because it's not at the right value. This will take some reverse engineering. That's for sure. So I have a solid red light, which means the throttle should be on, but you know, of course not. And the solid red light at the bottom, but the servo's not on, or the motor's not on, because the motor's not turning, which is great. So I have to find where the... Okay. These are the hobby wing motors, so let's see. Hobby wing ESC neutral PPM value. Hobby wing ESC settings. Red light blinking, any wrong cables connected. Well, the problem isn't the wrong cable. The problem is the receivers. Well, I don't have a receiver. I do have a receiver, actually. Give me a second. Whoa! I might have a solution to this. Hold on. Hold on. Okay. I might have a solution to this. Give me a second. So I have an actual controller, but it's for a drone. If I steal it, put it on that. It should work. Okay, let's see this. This is basically elaborative guess and check. So I have the controller here, and then I should have a receiver over here. Just gonna yank it off my drone. The drone doesn't need it right now, right? Rip the receiver off my drone and try to attach to the ESC now using this cable. And I'm going to reprogram my drone controller so that it is compatible with sending a signal to this receiver. RX standard. Output mode. Let's do PWM. Okay. And now it's on PWM mode, which means that one of these channels has got to be the right thing to output. Channel 1's throttle. Let's do throttle. See if this throttle will center itself. Let's do channel 2. Channel 2 should be the yaw. Since alright. Oh. UCO here, plug into here. Alright. Oh, this switch is loose. Okay, so test number 2 is seeing if this thing works. First I'm going to test it without anything, so the throttle's not even connected. Doesn't like that. Obviously. Now I'm going to go ahead and turn on the transmitter. And then it's going to send a neutral signal to channel 2. Well, this powered on. That's a good sign. And then let's see. Then move this. Okay, well I found channel 2 beeping at me. So channel 2 is channel 2 is the pitch on this controller, in which it's yelling at me because it doesn't like the pitch. Well, okay. Well, I'm gonna keep it at that for now, and then figure out. Well, so solid red light means it's driving it. So let me go ahead and unplug it and see if it actually has any voltage on it, so we can drive it. So right now it doesn't have any power, which is normal. That's normal. And then I increase the pitch. Still nothing. Decrease the pitch, still nothing. Alright, so it's some value of pitch. I guess, well, I have. Okay, well I can slowly increase the pitch until. Okay, I'm gonna. I'll do this. I'll slowly increase the pitch until it does a thing. It doesn't like self-calibrating for some reason. No, doesn't like that. Doesn't like that. Okay, that's not gonna work. I know. It's sending just this raw signal, TMKDK. So this would be sending a signal to the ESC. It doesn't matter what kind of signal it is. I just need a signal that will be able to turn on this stupid ESC when it powers on. So it doesn't matter what kind of signal it is, as long as it's the correct signal. Which, you know, is kind of hard to find right now. So I don't know what the correct signal is for this ESC specifically. Don't know if I ever will, but we have to figure it out and find out what it is. So this controller theory got busted right off the bat, so I can't use it anymore. And now I'm back to good old guess and check with the controller and seeing exactly which PWM value actually works for this ESC. Or so help me God. Speed 93. Oh, it's the wrong one. 79 to 115. The wiring is correct. It's just the ESC is being stupid. It doesn't want to be. It doesn't want to. It's saying it's powering on, seeing that my controller isn't calibrated, screaming at me because it's panicking and saying you're not at neutral throttle when even I don't know what neutral throttle is myself, and it won't tell me because there's no like audio cue like ESCs usually do. Here's a flow diagram in the link. Let me see. Oh, this is new. Oh, hold on. Let me take a look at the programmable items list. That might be helpful. Thank you, TMKDK. Okay, hold on. Let's see. User manual. Let me just save as a PDF. One of these is gonna get me the right answer. Ah yes, this is what I was looking for. Specifications, ADM 400A, that's correct. Brushed motors, motor limits, LiPo is 23S, it's fine. Connection diagram's correct. Extremely powerful brushed motor system. Okay, let's see that diagram here. ESC programming. Begin your ESC by calibrating your transmitter. We strongly recommend hobby wing users use the fail-safe function on the radio system and set FS to output off. What? Wait, does this exist? I'm gonna find a fix for this now because I left the other stuff at school. Okay, my transmitter. Turn on the transmitter. Ensure all parameters to the throttle channel are default for transmitter without LCD. Please turn the mount to maximum and the throttle trim to 0. Move the throttle stick to the neutral position and press the set button. There's no set button. Wait, is there a calibration thing for this? Hold on. Was I given a calibration thingamajig? Wait. Release the set button. Press and hold the set button, press the on and off button. Wait, what is that module? Switch. Well, their switch has a button. My switch does not have a button. So, okay, assuming that the switch is a thing, the throttle stick to the end position forward and press the set button. Throttle stick to the end position and press the set function. Is there a button on here I'm missing? Explanation for stuff. I'm not sure. I'm thinking that I'm missing, well, that set feature would be really helpful, but I don't know if the 880 ESC has that feature. Unless I get some programming cable attached to it, then I can set it manually, which I might have to do so, seeing how it looks. It's a bit stupid. Start mode punch, max brake force, BESC, running mode, lipo cells, timing. How do I manually calibrate this? Yeah, I'm not sure. Yeah, it's a slightly different model, but it has a better kind of like driver, I guess. And it's better than sitting here and trying to figure out like exactly how to turn this on, because all the other components are put on the pod already, or they're already there. It's just that this ESC does not like functioning properly, and it's giving me a great amount of grief. So I think I'm just gonna leave this here for now, I'm gonna come back to this later on. It's called 880. 880 Team KDK. 880. I'm gonna leave this here and come back tomorrow, and if I have any updates, I'll let you know exactly what I did and how to fix it. If there's no updates, they'll just be that. But I will get back to it tomorrow, because at this point I am near the point where I want to give up. But I'm sure tomorrow something will pop up and I will figure it out, and hopefully I'll find some way to manually calibrate it, because apparently it doesn't like working. Alright. That'll be it for today. So thank you so much for watching today's stream. It was great talking with you, and yeah, hopefully tomorrow I'll show you guys how I'll show you guys how the robotic arm works. It's actually pretty cool, and I'll attach the camera to it so we can see some live stream data from the pod. And hopefully I'll get able to get it working so that we can see it going forward and backwards. If not, I'm just going to build myself like a MOSFET circuit and make it do that. But alright, thanks for watching, guys. I'll see you all later. Bye for now. Oh, we have to raid someone, huh? I've been off Twitch so long I completely forgot how to, work Twitch. Let's see here. I'm on an infinite loop with myself. All right, let's see. ESC grief. Very fun. When you're trying to work with an ESC on a controller that's usually not what you use, but it's what you have right now. It's very, very fun and extremely painful, and Twitch is not letting me log in to raid someone. So, Twitch is not letting me log in. Oh, thank you. Okay, let me just log in real quick, and then we can see who's up. I forgot to do exercise. Okay, I'll do exercise next time, I promise. All right, no more excuses for the. Oh, I'll be right back. But we have a problem on our hands. We have a nice little ESC problem that it's not going to fix itself. So. I remember when I had my first ESC problem. It was a pain to solve. Okay, let's see who's online. Even if we didn't find the right, they most likely have some con feature. Yeah, they do have some con features usually. That's why I made this module. Usually for most ESCs that aren't like very strict, they will allow you to turn it on, have the wrong neutral setting, and then you can try to find the neutral setting by moving the throttle stick around. But this one, it's really protective. It says you better have the correct neutral setting when you turn it on, otherwise I'm not going to work at all. Let's go look at ducks. Six-figure duck channel. Alright, thanks guys. I'll see you later. Bye-bye. For real now.